Hello, everyone. Good morning, good afternoon, good evening, depending on where you are. My name is Ali, and welcome to today's Tech Talk, Accelerating Workloads and Bursting Data with Google Dataproc and Alluxio. We are very excited to have the Google Dataproc team here along with the Alluxio team. So before we get started, just a few housekeeping items. One is you can see our lovely faces. We are so excited we're doing a video tech talk today, so we hope you find this super interactive and feel free to ask questions at any point during the webinar, the tech talk. We have a questions box. It's located in your GoToWebinar control panel. You can pop your question in at any point during the tech talk, and we have allotted a good amount of time at the end of the session today to get to those questions. Next, we are recording this, so afterward you'll receive a link to both the recording and the slides, so keep an eye out for those. You guys join the same camera, very cool, I love it.
We'll be recording. Just two of me, but...
Great, cool. So with that, I am super thrilled to introduce our three speakers. We have Chris Crosbie and Roderick, both part of the Google Dataproc team, as well as Dipti Borkar, VP of Product at Alluxio. So with that, I'm going to pass things over to Chris. Chris, please take it away.
Hey, thanks everybody. So I am a product manager here on Cloud Dataproc. My name is Chris Crosbie. Next slide. Oh, we can go to the next slide.
Oh, looks like it's not going. There we go.
There we go. Yeah, and so as already mentioned, I am from Google Cloud Platform. If you're not familiar with Google Cloud Platform, well, this is a glamour shot of one of our data centers. And as you notice, there's different color piping. And that's not just to be, funky Google colors. It actually has some meaning. For instance, we cool all of our servers with water. So the blue pipes that you see, that's actually cold water going to the servers. And the red pipes are hot water returning from the servers. And that's just one of the many innovations that we have in our data centers that we are now offering to customers that want to tap into that same innovation. Next slide, please. And we had to get very, we have services with over 1 billion users, so we had to get really creative with our data centers. And so internally over the years, we've developed a lot of different types of services, ranging from software as a service to platform as a service, to infrastructure as a service. Next slide. And these are tools that we are now giving back to you. And so we really have a full-fledged cloud platform that's going to give you a lot of that same Google infrastructure, things that we really battle tested internally for years with Google Maps and a lot of other, and ads and various other services. Next slide. And we've been doing big data in particular for a long time. Back before that, word really was even a hot topic. It started with a lot of our research papers. We came out with the original MapReduce paper that eventually became Apache Hadoop in the open source, and even things like Bigtable, our paper for that became Apache HBase. And initially, we did the paper route and giving research back because we had so much tied to our infrastructure. But over the years, as we've moved into a place where we can actually give out our infrastructure to a lot of users as well and a lot of end customers, it's put us in a position where we can actually start releasing the entire code bases instead of just, okay, here's some research papers. And you may have seen that more recently with Apache Beam, which is a lot of our internal ways for moving data from point A to point B and doing complex transformations, as well as TensorFlow, a machine learning framework, where we've just given the entire code base away now that we have the ability for customers to come and just use these cloud technologies. Now, on the flip side of the open source, we also try to make it a fantastic platform for you to actually run a lot of this same open source technology, but without having to think about servers and operating system updates and like maintaining DDoS mitigations, that sort of thing, with a lot of these cloud services. Next slide. And the product that we are going to focus in on today is something called Cloud Dataproc, which is our managed Hadoop and Spark service. And there's a lot of benefits that customers have found as they migrate Hadoop into Google Cloud Platform. The primary one is just you get to start treating your Hadoop with that basic cloud value proposition of you just pay for the use. You have a set of jobs that you want to run, instead of a 5,000 node cluster, run a job, then take it down. You're not paying while it's not being used. We also will manage a lot of that hardware and software for you. We're going to create all the clusters that you need. You can get it whenever you want, get everything patched and up to date. And we give you still a lot of, even though we're managing for you, you have a lot of flexible configurations in this, the way that you run things. In particular, a lot of customers that come from on-prem environments where they've had to deal with things like yarn queues and trying to decide how to manage this multi-tenant environment. When they come to the cloud, they can start to break up their jobs for specific cluster types. So CPU-heavy jobs can live on one cluster. Memory-heavy jobs, maybe for your BI applications, can live in an entirely separate cluster, both be pointing at the same set of data. And the two, can be very independently and optimized. And the real big, key there is that now that you have that data in multiple clusters, that HDFS, it's not siloed per cluster. It's really more widely available, so people can do a lot more with the data across various applications. Next slide. And another reason that a lot of folks end up moving to the cloud, and this is something that came from an external analyst, is that it's a lot cheaper to run your Hadoop workloads on cloud, in the cloud, and Cloud Dataproc specifically. So we're about 57% less expensive than most of our on-prem counterparts. But even compared to other cloud providers like Amazon EMR, we're still finding ourselves, at least according to this study, you can go read it yourself, about 32% less expensive than Amazon EMR. And that's just because a lot of the tooling and automation we put around Cloud Dataproc. Next slide. And so there's a lot of reasons why enterprises migrate to GCP. Reducing that infrastructure cost is certainly one of them. But it also has a lot more to do with rapidly building new applications and new experiences, or connecting to different platforms that you didn't always have in play before, or even trying to make your teams more productive by giving them more flexibility. But for me, most of the time when I am engaging with customers, although we can save them money on their migration, it really is more about how do these customers gain more value from the data and start to put data into their daily operations to predict these different business outcomes. Next slide. And so again, that is why our goal with Cloud Dataproc is to combine the best of open source technologies with the cloud. And so we are really this open source engine for running all these various open source components, but in a cloud native way. So if you want to run Spark or Apache Hive, but then take advantage of the cloud's ability to auto scale, you can do that without having to think about that or set that up yourself. And then at the same, next slide. And so just some of the high level pitch, it is our elevator pitch is that it is our fully managed Apache Spark and Hadoop service, but really it's an engine for running all sorts of applications in that Hadoop ecosystem, whether it be Spark, Pig, Presto, or Druid. We give you very rapid cluster creation. So usually about a minute and a half, we can spin up a fully loaded Dataproc cluster. And when that happens, with a minute and a half startup time, that really lets you start to think about your set of jobs and your cluster as a single entity. And so instead of having to think about, okay, I have this cluster, now how do I optimize my job for that cluster? It just becomes one tightly integrated resource. And we even give you features like our workflow templates that let you start to think about that as a single entity. So your ETL cycle, it's just step one, spin up that cluster, it takes a minute, and there's not that much add on to your ETL cycle. We also give you customizable machine types, so you can get exactly the infrastructure that you need to match to your workloads. And then finally, a big goal with Cloud Dataproc is we do want to tightly integrate you with the rest of the GCP ecosystem. We want to get you hooked into things like BigQuery, our serverless data warehouse, or into Dataflow, our serverless way to run data pipelines. And so it's not to give you just yet another cluster to manage, it's really to get you using your open source tools that you might be using today on a laptop, but be able to apply them to cloud scale data sets. Next slide. And we have a couple different modes. One is this mode for job scope clusters or ephemeral Dataproc clusters, where you can submit a job or a set of, or a graph of jobs, deploy it on a right-sized cluster, and then have that torn down when it goes away. Next slide. But then we still, for a lot of users that do want to have a long-standing cluster, maybe for ad hoc users, we have a lot of features that support the idea of a long-standing Dataproc cluster as well, where maybe you have multiple users that come in, and then at certain parts of the day where you have a lot of users that are trying to run more applications than expected, you can have the Dataproc cluster automatically scale for you to meet those demands and then scale back down. Next slide. And the big key for when folks are moving from HDFS to, or moving into Cloud Dataproc, the first thing that folks tend to do is try to use cloud storage as their primary source and sink. And this is really key to letting you decouple that storage and compute. So typically in your on-prem HDFS cluster, you are tying a pretty expensive resource of compute to what is a relatively inexpensive resource of storage. And that's kind of crazy in today's terms, where you have the cloud and you can kind of decouple those two items and start paying cents on the gigabytes. And so that's usually the first key, is getting that that HDFS into cloud storage. And that not only lets you separate that storage and compute for cost savings, but it also lets you use a lot of new different data processing tools on that same data. And it's not just the applications that happen to be running on that HDFS cluster. Next slide. And so we do have a couple of differentiators when it comes to our cloud storage. First of all, you don't have to be afraid to use it as a destination. A lot of other cloud, we do have strong global consistency, which is something that not all the other cloud providers have. So in particular, I was working with one customer and they had tried for like 3 months to move over to a different cloud provider, but they have having their ETL jobs step on each other because they were trying to write to a destination, but it was the updates just were not as expected. But with cloud storage, they were moving over in about 3 days very quickly, just because we did have that strong namespace without having to put like a kludgy intermediate layer in between. Next slide. And the other advantage that we have in our cloud storage offering is that we do have all of our different tiers of storage is really just a pricing scheme. So you don't have to have a separate archive that you go out to and then have to restore to get data back from maybe your cold line storage where you're paying a reduced cost. All you have to do is go, set the storage tier, and that can even be automated. And then if you want to go back and run that exact same Spark job that you needed, you can do that. And we have 3 tiers, a regional storage, a nearline storage, and a cold line storage. The rule of thumb for each of these as it relates to Hadoop is your regional storage. This is pretty much your universal cloud storage for any workload, stuff that you intend to touch multiple times a month. Your nearline storage, this is going to take place for use cases that don't really need that high availability, or if you plan to touch it maybe about once a month. It's a file that comes in once, you process it, and goes into like a aggregations table, and you don't expect it to use it again. That would be a good case for nearline storage. And then cold line storage is what you don't expect to use again, that post-process data that you don't think you'll need, but for the reduced cost that you can get from this cold line storage tier, you can keep it around in case you were to ever go back. And the rule of thumb there is that's the data that you expect to use about once a year. Next slide. And so finally, the key here is once you're in cloud storage, now you've just made that, once you've migrated HDFS to cloud storage, and there's a lot of easy ways that we've made that possible, it opens up just a whole different world of tools that you have access to, whether you're using Hortonworks or Cloudera today, but also from Dataproc or Google BigQuery or Dataflow that can all be brought together around this new cloud storage object storage instead of just a siloed HDFS cluster. Next slide. And then finally, this brings us to today's topic, which I'm really excited about because this is a thing that our customers want to do often, which is they might see a lot of the benefits of the cloud. They want to run these variable workloads, or they have a job that just needs to run once a quarter that takes a ton of compute, and they just want to come rent some servers temporarily, but they still want to keep a lot of their data in their on-prem HDFS environments. That's great. We have a lot of capabilities for doing burst workloads, and I'm excited today to talk about our partnership with Alluxio that's going to offer essentially this architecture where I can balance data between both the cloud storage to get all the benefits I just talked about, but then still maintain my on-prem data source for HDFS as well. And so with that, I'm going to hand over to Dipti to talk more about this and how this works with Alluxio.
Great. Thanks, Chris. Thanks for the great introduction. And we're super excited as well to have Alluxio integrated with Dataproc, not only to bring back the lost data locality in these disaggregated environments, but also to pull remote data from either remote regions, on-prem HDFS, to give users a lot more flexibility into their workloads and trying to leverage the cloud much more easily than doing an entire big migration. So let's take a look at what Alluxio is, and then go into the details and under the covers and how it actually works. So Alluxio is an open source project. It actually originated at the Berkeley Amp Lab with sister projects like Spark and Mesos. And our founder and CTO, Hao Yuan, was actually working on his PhD thesis at that point. It was called Project Tachyon. Over time, it became Alluxio. It is Apache 2.0 license, so it's still open source, and you have the enterprise edition to go with it. And we're backed by Andreessen Horowitz. And the focus really is around advanced analytics and AI on data lakes. So data lakes like GCS, where or HDFS, it could be on-prem, it could be in the cloud, in different environments in this kind of hybrid and multi-cloud world. So where does Alluxio actually fit? Alluxio is a layer which sits between computes like Presto, Spark, Hive on the more structured data side of things, or Python-based frameworks like Caffe and TensorFlow, PyTorch, and so it sits between compute and storage, closer to compute, and provides a range of different APIs like HDFS, S3, Java, the GCS API, and so on, to interface with data, with the computes on top. And underneath, you have the storage systems. And so GCS, for example, is one of the storage systems. HDFS is another. And so you can essentially orchestrate data movement and bring data closer to your compute. Typically, Alluxio is co-located with the compute itself on the same hardware, the same instances. We'll take a look at what that looks like. But this brings back data locality, and it gives you many different ways to access your data. So many different APIs, so that you don't have to change your application. Changing applications, replatforming applications for new protocols is quite a non-trivial exercise. And so with Alluxio, you get the ability to keep your application as is, while still accessing the data wherever it might be. And all of this can be done on demand. It's a distributed architecture where it's scale in, scale out. You can add workers as you go. And so you get the full flexibility of the cloud, like compute offers today in the cloud, but for your data tier. And that's where it gets extremely interesting. So let's take a look at the architecture of Alluxio. So Alluxio is the master worker architecture. You might be familiar with it if you're familiar with the Hadoop ecosystem. And here you see, two different clusters. You have a Presto cluster. It could be, a Dataproc cluster where you're using Presto. There could be another one, which is a Spark cluster using Dataproc. Could be different sizes, etc. The Alluxio workers, the client is actually, just a part of the application itself. The Alluxio workers are co-located with the compute, and the master is responsible for managing the metadata, that is the file metadata of the files that are in the understores. We call them understores underneath Alluxio, and it only caches the metadata for the hot data. So this is essentially a hot data access tier that pulls in data on demand based on what the computer is requesting, based on what files it's requesting, and pulls that into the Alluxio cache, which is a tiered cache. And so once the data is in here, obviously your analytics, whether it's a Presto query, whether it's a Hive query, it will run significantly faster. Typically, analytical workloads reuse the data multiple times, and so that's where you see the benefits. When disaggregation of compute and storage is the modern way of architecting data platforms. But while it gives you enormous flexibility, it also introduces some challenges. It's lost data locality or accessibility. And so that's where Alluxio comes in and restores that, improving performance of the workload. Now, as I was mentioning earlier, with Google platform, it's incredibly easy to get compute going, to get storage set up. It's a matter of minutes. But even today, when you have data engineers working with data analysts or data scientists, and a specific data set needs to be moved over to the cloud, it becomes a little bit of a non-trivial exercise. You have to identify the data set, where it is, and if it's an HDFS, if it's a remote location, maybe write a script to prep it, copy it over. And many times what we see is you end up copying it many, many times. This obviously adds storage, additional storage costs, but also creates problems because it's very hard to sync the data back when when you have reads and writes going on in multiple locations. And so with Alluxio, instead of copying data, we obviously copy that data in, but it's not just the data that's being managed. It's also the metadata that's managed, and that's how we know if there are updates that are happening underneath the covers. So if this is a Google platform where you're running either on the instances, on the VMs, and you have Spark or Presto clusters, you can have Alluxio running within it, and it will pull data from GCS closer and get node level data locality for you within those environments, right? And so this is kind of simple use case where all your data is in GCS and you want to accelerate your analytics. So a great example of this is Walmart. They recently presented at our conference. They are running Presto in the cloud in GCS, and they use Alluxio to as a layer to bring data closer to their Presto queries that they're running at large scale. And so if we actually look at their some of the metrics that they're seeing, they see significantly consistent performance across their queries instead of spiky performance, and better, lower latencies, and more concurrency, right? So you're getting a lot more out of your resources in the cloud, and improving your experience, your user experience for your data analyst or for your data scientist, because the queries will return faster. If you have a user application, a SaaS application that's built on top of Presto or built on top of any of these frameworks, the experience that your end users get will be significantly better as well. So you're avoiding unneeded network access back and forth from your storage into your compute. So let's take a look at how Alluxio fits into Dataproc. Now, Dataproc has this great mechanism which is called an init action, initialization action, which allows for any external program application to be actually run within Dataproc. And so what we did is we used this mechanism and we created an initialization action, and that Roderick will be demoing in a little bit, so that you can actually have Alluxio pre-installed when you bring up a Dataproc cluster. And so it's a single command that you run to bring up that cluster, and it's quite seamless. So in terms of Dataproc itself, you have a choice of different computes. I've just shown a few here, like Spark, Presto, Hive, which tend to be the more popular ones that we've seen. And by default, without Alluxio, you can obviously still access GCS and access the data that you have there, run your workload, right? It works great. If you have performance requirements, lower latency requirements for both the metadata and the data caching, the metadata is more to know if there are updates happening underneath the covers and so on. You can use the initialization action, and I have the link here. We'll post it. We'll post the slides shortly after the webinar. And you have access. You will have access to GCS. That data gets pulled in, and it lives within the Alluxio cache within Dataproc on each instance. And so you can associate the compute and node with Alluxio and get node level data locality for significantly better performance. Now, If there are updates that are happening underneath the covers, you have the option of performing metadata checks where Alluxio will go back and check periodically based on a user interval that's set to check if there are updates and reflect those updates within the Alluxio cache itself. The cache itself is multi-tiered, and I'll talk a little bit about that in a bit. But this allows you to now speed up any workload. It could be structured analytics, which are more query-based, or it could be TensorFlow, it could be image analysis, it could be any kind of Python-based framework. So we saw here how it works with data that's already in the cloud, right? Which some of you might be at already. Now, even though the cloud has had huge amount of adoption, there are still a lot of Hadoop clusters that remain on-prem, and for various reasons. Sometimes it's hard to move this data into the cloud for security reasons. It might have PII information, etc. And so it's harder to leverage the cloud, particularly for compute in these scenarios. What Alluxio gives you the option to do is what we call zero copy bursting, where it can allow for this data to live in the memory of the compute, and so that it's not actually physically stored in GCS or in any storage device at all. And so let's take a look at what the thought process is typically for these users as they evaluate options to kind of burst to the cloud. The first one, there's a few other restrictions that you might have, bandwidth, utilization, so on. The first one is copy that data, right? Copy that data, the working set or that data set into GCS, and then run the workload on top of it, right? The second one is do a massive migration, so a lift and shift model, which might work well in some situations, but it is quite a long, 2-year, 3-year journey, as we have seen with some users. And the next one is kind of this approach where your data is still on-prem, but you are bursting it to the cloud using Alluxio's mechanism called zero copy bursting. And let's kind of walk through it and see what that looks like. So the first one, you already have, first off, you have a Hadoop cluster running in on-prem, very large. Typically, it's compute bound. That's what we notice. You have the Hive metastore there, remote as well. And you might have a range of workloads that are going on. We see everything from MapReduce to a large percentage of Hive, some Spark SQL, increasingly Presto that's being run, and then some AI workloads that may be running on the same cluster, or there might be a need to run it somewhere else. It's quite complex to manage once it gets to that point, and you have to scale out compute and storage together because they're co-located. Now, as we talked about, you could actually just run the compute in the cloud and access it over the network. It becomes network limited very, very quick because particularly with analytic workloads, the data sets that are used are very large, very common to have multiple megabytes of files, GB data sets, terabyte, multiple terabyte, petabyte scale, full data sets. And so it becomes very quickly, kind of eliminated from the set of options. The second is copying it over to GCS, which might be an option if it doesn't have PII information and so on. But there might be limitations to that, depending on governance criteria. And so that's where Alluxio comes in. So Alluxio lives in some ways, the workers live use the memory of the compute that is already running, and it does not copy all that data to begin with. As the compute asks for specific paths, it pulls that data set, what we call the hot data set, into Alluxio, and then reuses that for, if it's a Monte Carlo simulation, run it 100 times, or if it's training, running it multiple times, etc., and allows you to leverage that data. Now, you can perform writes back. There is a mechanism to do synchronous or asynchronous writes back to HDFS. And with HDFS, it also integrates with the iNotify protocol. And so if you have updates that are happening underneath the covers, Alluxio ActiveSync will be made aware of those changes, and the cache will be invalidated. And so all these mechanisms allow you to not create an additional copy, yet keep those two sets in sync and burst to the cloud. Now, in addition, Alluxio also provides a mechanism called policy-defined data management, which actually allows you to copy data into GCS over time as needed. As you get more comfortable using GCS and the cloud, you can move out data, and this can be based on different criteria that I'll talk about in just a minute. And so this allows you to leverage the cloud for compute capacity without expanding your on-prem HDFS cluster, and then over time, slowly migrating and moving data to the cloud as well. So under the hood, you might ask, how does that actually work, right? What actually happens? And so, when a request comes in, let's say you're asking for a file that's, /trade/US, the first pulls will be from underneath the cover, and you pull that data in. But once that file gets asked for again, Alluxio will simply, send that over from memory into Spark or to other frameworks, and it's much faster, right? And so that can happen again and again, and that's where you get the benefits of Alluxio. You can use a single layer for serving out multiple frameworks, or if you also have the option of having a layer of Alluxio outside of Dataproc that can serve multiple Dataproc clusters as well. Now, within Alluxio, it is a tiered system, as I was mentioning earlier. And so if you run out of memory, Alluxio is automatically going to manage the tiers for you. And let me go back here for a minute, and it will move data from memory to SSDs, etc. Make space in the RAM and pull that data, whatever data is needed, into the memory. We have an evictor that runs periodically that you can configure. You can also configure the cache policies, so LRU, LRFU, whichever kind of option you need can be used. Now, there's a few additional options, right? Caching on demand is great, but what if I want to pre-warm the cache? What if I want to pin specific data that's more important? Well, you see these little pins here. Those are meant to actually pin specific files or folders that are more important. There might be a certain join table that you're using in a very popular query that are accessed across the board, and you might want to pin them in memory so they don't get evicted. So you have the option to do that. You also have the option to do a distributed load, which is high performance, from GCS or a remote HDFS to pre-warm the cluster and then start your workload if you know exactly what data set you're looking for. And so those policies and capabilities allow you to basically tune Alluxio in advanced workloads to whatever you're looking for. Now, I mentioned earlier that we also have policy-driven data management, and over time you may want to move data from one tier to another, one storage system to another. It could be Hadoop, or it could be any object storage. It could be on-prem object storage. There's many different combinations. In this example, we define a policy where if the data is created more than 90 days ago, you can move the data, and here it's moving from HDFS to GCS. You can define the policy based on date accessed, based on date updated, based on date created, and also set the interval. So it could be an hour, it could be a day, and that allows you to have this movement that happens, periodically under the hood. Now, there's a lot of other tools that allow you to do this, but what's important is once you move data, what naturally needs to happen is the applications need to be made aware that this data has been moved. If you don't have a layer like Alluxio, which is managing the orchestration, the file paths, the URIs, and including the catalog, we just introduced a data catalog like Hive that attaches to Hive. If you don't have that, you will have to make a lot of application changes. And so what this does is it allows you to keep running the applications on top without any changes to names of your tables or locations of your external URIs in your metadata, in your Hive, etc. And so there's absolutely no changes needed for this to happen. And so with this, once you're comfortable with cloud like GCS, you can move data around as needed. Of course, Alluxio is built to be cloud agnostic, storage agnostic, and in some ways compute agnostic, and so it would work in any environment, in a hybrid multi-cloud environment. So with this, what I want to do is hand over to Roderick, who'll walk you through the demo of how Alluxio fits into Dataproc, and starting with some basics, and then moving on to remote access of HDFS. Roderick?
All right, thanks, Dipti. Hello, everyone. I'm an engineer from Google, and over here, I'm going to present, I'll do a demo here that show how does Alluxio work with Dataproc. Over here, I have created actually 2 clusters. Give me a second. So basically, the demo that I'm going to present here is we're actually going to do 2 of them. The first one is to demonstrate we create an Alluxio on top of Dataproc cluster, and we'll connect that Alluxio file system to use GCS as the under storage, and we'll do a series of file level operations to show how this system works and how you usually interact with it and what is the benefit of it, especially how to accelerate it and stuff in the memory caching capability. And then after the first demo, I'm going to do another demo, which is reading from a remote HDFS cluster, and to this Alluxio cluster, kind of demonstrate you how we don't need to either DCP or copy the data to this cluster, but we can use that Alluxio namespace to actually get the data here live. So with that, so over here, I already created a Alluxio cluster with the Dataproc initialization action. Alluxio will share the deck later, which will have the command and all the resources you need to create this cluster. Over here, so it's being installed under /opt/Alluxio. Over here, I already format the file system itself.
Roderick, do you mind bumping up your text just a little bit?
A bit more, okay.
Thanks.
Is that good? All right. So, so here's how I basically do a file system list, right? So what are files that's currently in here? I'm just going to give a quick run through of what is in here. So over here, the first is obviously saying this is the directory. This is actually when I format the Alluxio file system, it actually created this. And this is a file that I throw actually inside a GCS cluster. I can show you where is that. Where is that bucket? This actually is. So here is I'm listing the files inside my GCS bucket. So I basically mount this this directory to Alluxio as the root directory. So over here, the files are pretty consistent. Another information I want to share is that you see this 0%. This basically means this file, this object currently is not being cached into memory yet. So that means it's 100% on whatever under storage system is. From here, you see the file status and the last access time. And there's information on persisted, which we'll later see another case for non-persisted. This basically means that persisted means the file is being persisted into the under storage system. And non-persistent means that only the changes only happen in memory at the moment. It's not being persisted. You can force the persisted or set some kind of policy to auto persist into different modes. For example, synchronous mode versus asynchronous mode. Okay, so with that introduction about the basic information that Alluxio LS gets you, let's do something quick. Just see, I have a sentiment .csv file which contains a lot of tweaks. Trying to. So let's do a just count. and see how many the word puppy show up. So this takes 2.8 seconds. And oh, let me just show you what's in this file first. Yeah, this is pretty much that. That's a cat short. Remember that now I have read the file already, so this file should already load it into the Alluxio system. So now you see it's 100% in memory already. So I can do this again and again. That will utilize all the memory kind of capability. This is cached there. So in this case, this file is not big enough to show a significant enough benefit, but you can still see that time reduced from almost 3 seconds to down to 2 seconds-ish. So with that, then the next step we can do is let's copy a local file to Alluxio. So here, copy the end user license agreement to the Alluxio system. Now it says completed. So let's give a look. Now you see that the license agreement file is already there, but it says non-persistent. So that basically means you won't find on the under storage system, which is GCS. Let's do listing. It is not there. So how do I make it there? So over here, I did not set any automated policy to do this, so I'm going to force it to get the file there. So call it persist. And found one file to persist, and then it succeeded. Now let's check it out in the GCS bucket. If the file is there, it is indeed there. So that means our operation succeeded. And next thing I want to demo is, so now you have these files inside of memory already. What if a memory gets full, or I don't want to cache this thing because I don't use it over and over again? You can also evict that from the memory using the free command. So now you see that this license agreement file has been evicted from memory. It's not being cached anymore. So that concludes our first demo, right? So that works with the GCS bucket. And so I have also created another cluster, which is another Dataproc cluster in the network. It's connected. And let me enlarge this. Apologize. So this will simulate a remote HDFS cluster. You see these clusters have nothing in common. They're not even sharing the same bucket, but they can access each other's network, right? So so far I have nothing in this. I have just very small things inside of this HDFS file system. So I pre-populated the HDFS file system with Alluxio folder. And inside of that folder, I uploaded a log for j.properties file and that same segment.csv file. So let's configure the Alluxio cluster to access this HDFS cluster. So the first thing you need to do is you need 2 files actually from this cluster. So what are they? They are the config files for the Hadoop system. So you actually need this core-site.xml and the hdfs.site.xml. So what this includes is basically a set of configuration for your HDFS cluster. So I copied those files through the network to this Alluxio cluster, and I put them in under this directory of test HDFS config. So these are the same one that I copied from the HDFS cluster. So how can you make sure that Alluxio can load them, which is you can configure the conf Alluxio-site.properties file. and you basically add the HDFS configuration point to those two files. And by the way, these are all documented in the documentation section on the product. I'm not going to go through that or pre-configure this. So the next step we can do is I'm just going to load something earlier. We can mount, use this command to mount that this HDFS cluster in this folder to the /HDFS directory under Alluxio. So let's list what's in there. And I found a new directory here. And if I list that, I should be able to see the log4j.properties file in the sentiment.csv file. There you go. I can also access them. So I'm just going to do a cat HDFS log4j properties and get all the content here. So I did not set up anything. I did not copy those files to this Alluxio cluster. So this proves that our global namespace works fine, and I don't need to, copy everything over and do the lift and shift and make sure that everything gets copied in order to do any of the analysis or the jobs.
Roderick, can you also bring up the UI, the Alluxio UI on port 1999, just to kind of take a quick look?
Oh yeah, that's a good point. That probably needs, actually I need that to log into a different machine. So let me look for my Dropbox machine. Yeah, it's a good point. Developers usually just do everything.
Yes, stay on the command line, yeah. Yeah, as he's bringing this up, yeah, so essentially you can mount, GCS or HDFS or multiple HDFSs, multiple buckets, GCS buckets into Alluxio. And while he's kind of showing the persist and the free kind of manually, when you're running a workload, it obviously happens automatically. So the eviction happens automatically, but you do have explicit explicit control over files and folders as well, which for a demo, it kind of helps you see how it works underneath the covers.
Okay.
999. Yeah.
Oh yeah.
99. Yeah, there you
go. Oh, sorry. 139.
3, yeah. 4 9s.
Oh.
That's all right. You can keep going if you're not able to access. Yeah.
I get the wrong name.
There you go.
There you go.
Yeah.
Yes. This is very similar to HDFS interface. So you can browse the content in here, and you can see what's the memory status of the permission and configurations of the workers. This is only a one node cluster for demo. That didn't have a whole lot of things. There we go. With that, that concludes my demo.
Great. Thank you so much.
Great. Thank you, Roderick, Chris, and Dipti for some awesome content. So just a reminder, if you do have a question, you can go ahead and enter it into that questions tab on your control panel. And we do have a few that have come in. So why don't we go ahead and get started with the few minutes we have left. First question, I believe, is for Chris. Chris, can you give some specific examples of the types of jobs that users will run with either long-standing or ephemeral clusters?
Yeah, the jobs would just be the things that you would expect to find in a Hadoop ecosystem. So these would be Spark applications. They might be Presto SQL queries. They could be anything related to like Spark R, pig jobs, or just your legacy MapReduce, MR2, Hadoop type jobs. Those are just a few of the examples of the job types that we support, but really there's a whole ecosystem there.
Cool, great. Next question for Dipti and maybe Roderick as well, if you want to jump in. Will Dataproc and Alluxio work in Kubernetes?
Sure, I guess a two-part question. So there's the Alluxio bit and then the Dataproc bit. So Alluxio does work really well in Kubernetes environments. And so we have our container. We also have our Helm charts that allows you to kind of easily deploy Alluxio within a Kubernetes environment. And we are seeing a lot more K8s environments from a user perspective on Slack, or a lot more requests. I would say even in over the last 6 months. Typically, Kubernetes hasn't been big for like these advanced analytical workloads, but now we're slowly seeing Spark, Presto getting deployed within Kubernetes environments, and obviously Alluxio kind of fits in. Now there's the Dataproc piece, which the team actually had some great announcements earlier in the year. So Chris or Roderick, maybe you want to talk about it?
Yeah, sure. So we are actually looking into better support for Dataproc on top of Kubernetes. Being from Google, we're probably a little biased that we do think that is the way that most cluster administration is going to head in the future. We have a lot of customers today that have moved over to Kubernetes, and what they're finding is they don't necessarily want to have this separate yarn cluster anymore. They want to have these everything managed, all their websites, all their BI applications, everything else in their Kubernetes cluster, and then want their business, their big data applications there too. So just recently in September, we launched an alpha of a feature for Spark on Kubernetes through Dataproc. And essentially what we're trying to do with Kubernetes and Dataproc is we don't plan to give up yarn or traditional VMs anytime soon. But what we want to do is have a unified control layer that sits across both yarn and Kubernetes. So your in-cluster administrators don't necessarily have to worry about is this a Kubernetes application, is this a yarn application. In developers can choose which they want to do. Maybe they want to start with their notebook in a VM environment, but then if they want to have a production job that is linked to a Docker container with all their dependencies, they can do that, and it's all one set of permissions, all same set of controls across Cloud Dataproc. So if you're interested in that alpha program, please feel free to reach out. We can get you in there.
And we're excited about the alpha program as well, because Alluxio can be a nice data access layer within Kubernetes, whether in Dataproc, as well as we see it across other environments as well. And so hoping to, at some point support that once it's GA and actually be help with the data orchestration within the container orchestration.
Great. Dipti, you touched on this, so maybe expanding on it. Migrating or bursting workloads, which approach may be better? Can you talk a little bit more about both of those approaches?
Yeah, so as I mentioned, depending on where you are in this cloud journey, you might already be all in the cloud, right? Or you might be on-prem and you're looking at ways to move to the cloud. If it is an option for you to, migrate over and do the lift and shift, that's a good option. It allows you to, get the benefits of cloud quite easily. But some of these Hadoop clusters are rather large, and it's a non-trivial exercise to kind of go through that process. And so Alluxio just gives you, a way to take one small step into the cloud world and utilize the power that Google Cloud has and that Dataproc has to expand some of your workloads into the cloud. And so I think that the architectural decisions need to be made, as you're working through this journey. And, you kind of have to think through what the best approach would be. Sometimes we see users take an approach where they go BU by BU and business unit by business unit and look at what data sets they're accessing and start off with that. Or maybe look at start off with the smallest framework that is in their Hadoop cluster, right? And let's say it's majorly MR and Hive, and there's little Spark. Then you start off with that and get a sense of how it'll work, and then start moving the other workloads around. Chris or Roderick, anything more to add to that?
No, that's perfect.
Yeah. I think we also seen, this is mostly also depends on where you are, pretty much like you said, where you are in the journey. It also depends on like your application and the architecture. For example, we sometimes seen if you have like a lot of separated jobs, they don't have to, put it together in the graph. Then it's kind of easy to do the lift and shift migration because you don't really care about the interdependencies of those. When an interdependency comes in, typical for very large enterprise organizations, that's going to become a little tricky, right? If we're not using tool like Alluxio, then you have to piece by piece migrate them over, and then have to make sure that you can migrate them quickly, so that fits in your business timeline. If you have Alluxio, then you pretty much have the option. Don't have to do this data migration and have to make sure that data is consistent after you can copy everything over, and engineering the stuff in the middle. So this is a significant benefit over here.
Great, thank you both. So with that, we are coming up at the top of the hour. So thank you everybody who has stuck through this with us. We hope you enjoyed the content and the demo. Just a reminder, you will receive a link to both the recording as well as the slides after this. And I think Dipti wanted to just share quickly the page on our website.
Yeah, absolutely. So if you are interested, download, you can start off with the tutorial, the Dataproc tutorial, which gives you the links to the in action, and you can get going here. So it's really easy to get started. It's a step-by-step process to get you going.
Cool. All right. Well, thank you, everybody. Thanks to the presenters for the great tech talk, and we will see everybody next time.
Great. Thanks, everyone. Bye-bye.
Bye.
You have been removed from the call.